Today, our group will present Leucaena species for various applications in the environment toxicology as an indicator species. The title of the project is Various Use of Leucaena Leucocephalafor in Environmental Toxicology. Our team is from Maria Juliana Diaz, Karen Sofía Valero, and Diego Antes Genesi. Introduction. The different anthropogenic activities generate multiple environmental problems, such as the release of pollution in the environment, affecting the geochemical cycles that interact in the ecosystem and the organisms that reside in them. Subsequently, following up these problems, environmental toxicology is incorporated by carrying out biomonitoring with indicator species to measure the effects on organisms. Leucaena leucocephala or Leucaena sp is an important leguminous plant with the capacity to grow in different environments in the tropics. It has a great potential as a pasture species that provides source of crude proteins and other impact nutrients for livestock production. In terms of environmental toxicology, it is known as a soil bioremediation space to mainly for phytoremediation of soil contaminated with heavy metal at TPH or total petroleum hydrocarbons. Um, these metals extracted from the soil is accumulated mainly in the roots, decreasing the concentration of the proceeding to the implementation of biotechnologies such as phytoremediation. The process of pollution extraction in the ecosystem are called phytoremediation and are processes that are carried on in situ or ex situ. A method that takes advantage of the capacity of certain plants to absorb, accumulate, metabolize, volatilize, or stabilize pollutions present in the soils or water or sediments such as heavy metal, radioactive metals, organic compounds, and compounds derived of the petroleum.
Effects. Copper. Low dose of copper stimulates plant growth of Leucaena leucocephala, but high dose cause a toxic effect in the aerial part. Cells accumulate lower copper content than zinc, which degrades in the both organs, especially in the presence of mycorrhizal, fungi, and rhizobium. This can help to disease strategy for phytoremediation as part of the management of contaminated agriculture soil for use in the production of biomass even with high copper content. Iron. The excess and accumulation of iron in the rocks causes decrease in the biomass of Leucaena leucocephala. Iron phytotoxic can occur in the two ways, indirect or direct. Indirect, with iron plaques are forming on road surface, affecting nutrients uptake. Indirect, when iron is absorbed and accumulation in plant tissue and appearance of brown spot of loss. Also, new leaf tanning, which occurs due to the accumulation of leaf tissues and causes damage to cellular components. Total petroleum hydrocarbons. These species exhibit spontaneous tolerance to oil in the soil, declared settling, height and road leg due to effects of oil in the soil. High concentration of hydrocarbons prevent the absorption of water and nutrients due to the formation of hydrophobic layer on the rocks.
Irrespective, preparation of the seeds of Leucaena leucocephala is carried out, taking into account sterilization, rinsing, and pre-germination to later transplant them to the study site. Some of the characteristics observed are depth, texture, and pH. The variables evaluated are plant age, branches, stem diameter, leaf per plant, leaflets, leaf length, leaf width, root length, root volume, leaf dry weight, stem dry weight, stem analyte content, leaf analyte content, leaf area, root nodules, and nodule dry weight. Leucaena leucocephala is a good alternative to associate with other species since it's an arboreal legume that provides benefits to the soil and is a great indicator to study the contamination of ecosystems. It also generates flexibility in the branches, increases nitrogen fixation, decreases mimosine content, has high regrowth capacity, high nutrient supply, improves soil fertility, prevents erosion, improves soil structure, has great ecological value and persistence after planting. Its deep roots accumulate and recycle minerals: phosphorus, potassium, magnesium, calcium, and boron from deep soil layers.